Hi, this video explains how that maximum likelihood is estimated by using the Bayesian theorem, right? So here already in the previous video we discussed there is the random noise available in our given data set. Random noise is added into our data set. The data set is having the features x1, x2. This is actual output label, right? So each sample is having the values 0 0.5, 0 0.7, this is yes, 0 0.1, 0 0.2, this is no, like that samples are there. So the each sample is considered, there is the noise is added with normal probability distribution. The maximum likelihood hypothesis using the probability is given HML, maximum likelihood, from available n number of hypotheses. From the hypothesis space we have to identify the maximum probability value. Maximum probability value, that is the optimal value. Assume we are having h1, h2, h3, h4. So four hypotheses available in the hypothesis space. Among these four hypotheses in the hypothesis space, whichever hypothesis is provide you the optimal solution, that hypothesis, that is with minimum error, whichever hypothesis is provide you with minimum error, that hypothesis will be called maximum likelihood hypothesis. That is the thing, maximal value hypothesis from the hypothesis space, which is providing you probability of data given hypothesis. Okay, so by using the data set D, okay, from the data set D, whichever hypothesis is provide you maximal probability with minimum error. Okay, maximum posterior probability, right, with minimum error, that is called maximum likelihood hypothesis. So we can derive this maximum likelihood hypothesis using the probability density function. uh, so here the which is having the probability density function small p. We are taking the set of training samples x1 to xm, right? This is called training samples, which is having the m number of samples with two features. Here in our example, the actual output is represented with capital D, which is having the sample 1's actual output, mth sample actual output. The value output is here calculate having the output, actual output plus error. That means our sample is having the predicted with output with error. Assume training samples are mutually independent. Yes, each training sample is mutually independent given hypothesis. So which can be calculated. Maximum likelihood hypothesis is product of I equal to 1 to m number of samples, then probability density function of output. Di means output, probability of Di given hypothesis. So here probability density function equation is given 1 divided by square root of 2 pi sigma e power x minus mu whole square divided by 2 sigma square. Here sigma square is the deviation, and mu is the mean. Right? So now, which is written using the normal distribution. Here when we are deriving the maximum likelihood by using the probability density function p for each and every data sample. So I is from 1 to m number of samples are there for first sample, and it is for mth sample, so it will keep on increase. So we have to substitute appropriate mean and sigma square variance to all the samples. Here you see the probability of density function value is this one. When you are substituting the values, then uh, you will get the hypothesis, maximum hypothesis. Then here you can apply the natural logarithmic. So here we are applying the natural logarithmic to the given each data sample. So I is representing the sample, data sample. You see, this is the actual output. The h of xi is the predicted output by the model. H of xi is predicted output. predicted output by our model. Then DI is actual output given in actual output label given in the data set. So we are checking the difference between these two by using the mean square error. You look at here, we are squaring the error, we are squaring the error. Okay, so by using that, we are calculating the error, what is the difference, right? So for all the samples from I equal to 1 to m, so when you are applying that, we can calculate the error. So here maximize the quantity which is equivalent to minimizing the corresponding positive quantity. That means here when you are calculating the value, if when you are calculating the value which is giving you the difference between actual output and minimum actual output and predicted output. So based on that, for each and every iteration, you can update the parameter, and we can minimize the loss. So each hypothesis is each data sample is related to the hypothesis. So by using this, we can calculate the maximum likelihood. So here, how it is predicting the probability in how your maximum likelihood is used in the predicting the probability. So here we are taking both sample xi and di as a random variables, assuming each training sample is independent to each other, right? This is the given formula for probability of data given hypothesis. So this is the probability density function. Then we can rewrite this by using the given formula, right? So here this is the uh, actual output of the sample xi given hypothesis. That is the meaning of this one. So here, if it is consistent, we can take this one h of xi. If it is data set is 0, the two we are taking for binary values. You look at here, this is for actual output d1 predicted output, then 1 minus given predicted output, which is for actual output is 0. When you are applying this, then we can rewrite the maximum likelihood hypothesis product of I equal to 1 to m. This is predicted output, then 1 minus predicted output. So this is the actual output. Okay, actual output and probability of xi. So the constant independent of h, the probability of x is here xi. This is the constant which is independent of the hypothesis, so it can be ignored. So this is removed, this probability of xi is removed and rewritten the equation. Finally we are applying the log likelihood, so natural logarithm is applied for each one. So this is the loss function, right? This is the loss function which is look like a binary cross entropy. So here we are identifying the applying this loss function to find out the error in the given data set. So this is the way to calculate the loss in the maximum likelihood. Thanks for watching.